Okay students, so yesterday we started elasticity or mechanical properties of solids, that is the name we call elasticity also. So in that we have studied what is stress, force by area, what is strain, change in dimension by original dimension. So linear stress is the weight applied or the weight applied along the cross-sectional area, in the direction of cross-sectional area. Okay, then change in length by original length is the change in dimension, correct? Then rigidity modulus, Young's modulus is what? Stress by strain. Then we came to shear stress, the tangential force, that is the shear stress, the displacement of the body. This may be the situation first, then displacement happens, that by this length, that is the shear strain. Tangential length divided by that area is what is shear stress. Then volumetric stress, if you put something inside the water, it will exert pressure on that, it will crunch a little. So change in volume by original volume is what? Volumetric strain. The pressure, that stress is actually pressure. Force applying by water or liquid on the body is pressure. So that pressure by change in volume by original volume, that is volumetric strain, that is nothing but bulk modulus. So modulus of elasticity depends on the material. So all these things we have seen. Then the graph also, stress strain graph, proportional, Hooke's law is obeyed, stress is proportional to strain. After that Hooke's law will not be obeyed. What will happen? It will go up to elasticity limit, where it can come back to original dimensions once the force is removed. Then after that again, if we apply stress, strain will happen and it will not be able to come back to the original dimension then. Okay, then again further there is chance that it will break. So how far it will break? Okay, after how much strain it is going to break? If it is lengthy, then it is ductile, malleable. If it is less, then we can say it is brittle. So we will start doing problems today. We will start with the simple problems, then we'll maximum how much complex can come, we will see to some extent. Okay, so first problem, A and B. Okay, A and B, two wires. Okay, radius of A is twice that of B. Same force is applied on both. Same force is applied on both. The stress on B is So what is the first one, sir? So stress on B comparing to A, this is what the question is, correct? So force by area, So when you solve these kind of questions, please don't write everything on the paper. Okay, avoid writing everything on the paper. Instead of that, what you should do, mark all the constant values. So here it is going to be what? Pi r square. So this also, mark all that, avoid all those things, and whatever is required, just take that alone. Things will be easy. So stress on B. So what is this? Stress is inversely proportional to square of the. So stress B divided by stress A will be what? RA square divided by RB square. What they are saying, RA is 2RB. So this is going to be 4RB square divided by RB square. So SB is going to be SA. Just like that, make the things as easy as possible. So 4 times that of A. Stress on B will be 4 times that of A. Clear? Okay, another question is, okay, a weight is suspended like this. Weight is suspended like this. The area of cross section is A. Area of cross section is S. This is area of cross section. Okay. What they are asking is, what is stress? What is the stress at this point? And this is 3/4L from this lower end. 3/4 from the 3/4 length from the lower end. Okay, so options are, suppose if this is W1, okay, this W1, and the weight of the this rod, this complete rod has weight W. Okay, the rod has weight W. W1 is suspended. What is the stress at this point, which is 3/4 of L from the lower end? Okay. Second option. Think once again. What is the answer, children? Option C. So what happens is, now we are interested here. 3/4 of length is already came here. So this is going to be, the stress is actually, stress is equal to force by area. Force means definitely W1 will come. So we are specifically asking here, we need to consider this weight also. The total weight is W, 3/4 of this, 3/4 full is L. If this full is L, on the lower side. Okay, so the weight of this part is going to be W/4, and weight of this part will be 3/4 into W. Area of cross section is same, no? Okay, so W1 plus 3W by 4 area of cross section S. Clear or what?
W will be acted on the center of mass.
That is true. If the whole weight is acting on the center of mass, the whole weight of this complete thing is acting on the center of mass. But since they are asking at this point, that is the reason we are taking like this. Length of the rod will increase by its own length. So there we will have to take this length only. That is why. Clear? Okay. Now I shall give you one question. Okay. So that is that question we can see in many standard books and all. Okay. Even though this is little bit as may feel a bit difficulty in that problem, it is good to solve that. Okay. So that is nothing but this is something like this. Okay. So here force is applying in this direction. Force is applying in this direction. Here this may be attached, or force can be applied in this direction also. Clear or what? Either this will be attached or force in order to make this thing effective. Likewise. So thing is, we consider an area this way. So this is PQ. Suppose if we consider an area like this. Okay, so this is PQRS. PQRS. Clear? This angle is theta. This angle is theta. Force is happening in this direction. So actually there is area of cross section is this. Area of cross section is this. So here the question is, what is the tensile stress on the area PQRS? Tensile stress on area PQRS. This is the question. Okay. So options are F by A, F cos theta by A, F cos square theta by A, F by A cos theta. And sir, if you are getting, please tell me. So students watching online, please do this. Getting? Okay, so shall I start doing? Anyone getting the answer? No? D. Okay, any other answer? Who got D? Mukesh. D yarku? D. Aslam? Aishwarya? Pooja nge? Getting? Chami? What answer you are getting? Okay, see, look here now, this tensile stress on PQRS means PQRS is this area. PQRS is this area. Area is a vector or scalar? How many of you say area is scalar? Dhairima, raise your hands if you have any thoughts like that. Nitish, area is vector or scalar? Clear, no? Okay, all of you know that. Good. So area is a vector means this will be the direction of PQRS. We should understand that if this is theta, this also will be theta. If you have any confusion, just inclined plane. If this is like this, suppose if you mark like this, what about this? This is going to be theta. So if I mark like this, theta, correct or what? Understood? If this is theta, this will be theta, then this also will be theta. So same way, this is theta, this angle will be theta. So what we need, tensile get up. Look at him. அவருக்கு குறைதானே தூங்கிட்டு இருந்தல்ல ஒரு தப்பு கிடையாது ஆனா நம்ம முழிச்சு விட வேண்டியது we should wake him up, right? கரெக்ட்டா? or we should wake her up இல்லையா? பிருந்தா come on, get up. பிருந்தா தூங்கல ஆனா அவர்கிட்ட சொல்ல வேண்டாம். பிருந்தா ஓகே, ஆர் யூ ஓகே? இப்போ தூக்கம் இல்லைல்ல? அந்த பையனுக்கும் எனக்கும் மட்டும்தான் தெரியும் தூங்கிட்டு இருந்தேன்னு. இப்போ ஓகே தானே? தூக்கம் போச்சா இல்லையா? ஓகேன்னு சொல்லுங்க. All of you. அவர் மட்டும் சொல்லக்கூடாது. All of you should say. Otherwise everybody will understand that. Okay. So தூக்கம் வந்துச்சுன்னா what you can do now? See, don't consider me as your teacher. Just consider me as your friend. So if you are feeling sleepy, what you can do? If you are okay, எல்லாரும் தெரிஞ்ச பிரச்சனை இல்லைனா, you raise your hands. Then இப்படி காமிங்க. Then I will talk for some time. ஒரு 2 minutes பேசலாம். Sleep will go, then again you will continue. Okay, now come here, pa. All of you look here, very important. Okay, see, this is the direction tensile stress. If we need to find that area, we should take, and the force acting perpendicular to that area we'll have to take. So if this is the direction of F, then this is going to be F cos theta. Fine, done. So cos theta we got. F cos theta divided by area of PQRS. Right? Now area of PQRS is equal to what? Into what? PS, PQ into RSA. PQ into PS. Now this area and this area will be different. That is why we are not taking. So PQ into PS. That. Ipo, just take. Suppose if this is X. Then what is cos theta? px divided by what? ps. So can I write px is equal to what? ps is equal to what? px by cos theta. So what will come here? pq into px by cos theta. Now how I can take this px out? pq into px by cos theta. Shall I ask you one thing? This pq into px is what? pq into px is general area of this one. So can I take this as area A? So what is area of PQ as? A by cos theta. Correct or what? Correct or what? A by cos theta. Now the things are easy. Tensile stress. Stress is equal to what is force? F cos theta. Divide by this one is A by cos theta. So the answer is F by A cos square theta. Clear? Understand? Okay, children, right. A question, a sub question of this. Okay.
So the
Now,
common area is
common area is
taken from the common area that is taken from whole.
the common area is taken for, suppose if you cut this, you will be getting a cross section area. So that is PQ, what I have written, no, X. This side I do not know, this side is not R, this side is actually, if you go to the other corner, that side. So A. Suppose if you consider this one, area like this is what is PQRS. Exact cross section area is A. Exact cross section area is A. Suppose if you cut like this area will change. This area is more than cross section area.
Okay. PQ area of PQRS differs by cosine of that area.
We cannot say it is cosine of that area.
Angle.
Angle is theta. Clear? Okay. We discussed. Now the question was tensile stress. Question was tensile stress. What is the shear stress? What is the shear stress on area PQRS? What is the shear stress on area PQRS? Shear stress on the area PQRS. What is the shear stress on the area PQRS?
0 degree. How is it area vector இருக்கும் அது question.
Area vector இருக்கும்.
Area vector f cos theta 0 degree. Then how we told in some force should be perpendicular to area. Here the is 0 degree.
That cos theta, that theta is not the angle between force and area vector. That theta is the angle between cross section area and the given area. See, this area vector is also acting like this. This area vector, the area PQRS, is also acting like this. Force is equal to?
Force should be perpendicular to area. Here the angle between force and area.
Force is perpendicular to the surface. Force is perpendicular to the surface. Not area. புரிஞ்சுதுங்களா? Okay, so here in this question, what is the answer, children? Okay, what is the answer of this one? This one you might have done easily, no? The headache is only just finding the area PQRS. Remaining things are easy. What answer you are getting? B. So this is nothing but this is the tangent force. If this is force, this is angle theta. If that is f cos theta, this is going to be f sin theta. F sin theta. So here the shear stress on area PQRS is going to be, this is tensile. So shear is going to be so in numerator this is going to be f sin theta cos theta by a. F sin theta cos theta by a. So if we put a 2, we can write this as sin 2 theta. Correct or what? Okay, so here what also there? A is also there. So f sin 2 theta divided by 2a. So answer is B. Clear? Okay, fine. Understood? Any doubt? Last step. See, what they are asking is shear stress. What they are asking is shear stress. So yesterday we have seen, okay, any thick book? Okay, so suppose if this is the area, if you are suspending like this and if you are acting a force in this direction, weight in this direction, we can say tensile stress. But suppose if you are keeping the book like this and if I am applying a force along the tangent, then this displacement divided by this length, that is strain, and force I am interested is in along the tangent. Okay, just like we are doing this, no, just patting on the head. Okay, tangential force. Okay, this is what is tangential force along the surface, Now here when they ask tensile stress, we are interested, which area they have given? They have given this kind of area. When this area is given, we are interested in the force in this direction. So force should be perpendicular to area, means perpendicular to the surface of the area. Direction of area is this, not direction. Force should not be perpendicular to the direction of area. Force is perpendicular to direction of area means the things will come like this. It should not be like that. Force should be perpendicular to the area, but direction of area is this. Clear? So that is was tensile. Understood? Right. Now suppose if this is the area, we are interested in shear stress. We are interested in the if either of the force in this direction or that direction, either this direction or that direction. Suppose if this is the area, force in this direction or this direction, correct? So tensile stress means we are interested in the tangential force. If this force, if we resolve in this direction and this direction, if we resolve in this direction, then exactly 90 degree another component also can be there, also will be there. So this is the tangential force this time. So shear stress will be tangential force divided by area. Area is A by cos theta. General area divided by cos theta. Remaining things what we have written? What we have written? Just simply simple trigonometry. Okay. Maybe that step you did not understand. Fine, no issues. Okay. So F sin theta divided by A by cos theta. So when I send it numerator, this will become S sin theta cos theta divided by A. We know that sin theta cos theta is equal to sin 2 theta. So what we did is multiplied by 2, put a 2 here. So this term we made it as sin 2 theta. So that is the answer, came like this. This one. Clear? Understood or what? Fine, that's it. Okay. At what angle this shear stress will be maximum? Third question. At what angle this shear stress will be maximum? What angle shear stress will be maximum? 45 degree, sin theta. Okay, sin theta maximum value 90 degree. Don't write that mistake. Okay, so shear stress will be maximum at theta angle is theta is equal to 45 degree. Okay, clear? Shear stress will be maximum. Correct? Shear stress will be maximum at theta is equal to 45 degree. Clear? Another question. A wire is stretched to double its length. A wire is stretched to double its length. Another question. A wire is stretched to double its length. Strain will be. A wire is stretched to double its length. What is the strain? 1. Correct? No? 1. Okay. So write 2. Okay. There are chances. This 2 is given to give us negative marks. Okay. Correct or what? Okay. So this is just for your understanding. At least some students don't get confused. Okay. Thing is, Nitish, look here, baby. This L, it is doubled its length means strain change in length divided by original length. E like change in length is doubled. So if we put here 2, what will happen? First option is here 2. It's very simple question. Careless mistake in the hurry-burry. We will do that mistake. So this is nothing but final length minus initial length divided by L. If we do, we will be getting 1 here. So very careful. Easy concept, but they will. Okay children, see another question. Stress, strain. Okay, all are straight line. Okay, C B A. Okay, rubber. Okay, so A B C, rubber, steel. Okay, rubber, brass, steel. Okay, B, brass, steel, rubber, steel, brass, rubber, steel, rubber, brass. So S is steel, B is brass, R is rubber. Okay, which option is correct? A, B, C. Option A. Which one is more elastic? Steel. Steel is more elastic. Steel is more elastic means, suppose if we consider a line like this, for say for example for a constant stress which is having least strain, that is what is more elastic. So which will be the answer? Understood or what? Tangam? Understood or what?
Steel is more elastic.
Steel is more elastic. So what they are asking is which one is steel, which one is brass, which one is rubber. Mukesh, புரியல முகத்தை பார்த்தா இது புரியல, அப்புறம் ஏன் கேட்கல? நமக்குள்ள தானே always don't hesitate பண்ணக்கூடாது. If you have confusion please ask. Okay, எதுக்கு why so much formality and fear இருக்கவே கூடாது. அப்படி suppose if I feel that someone is very hesitant every now and then, புரியுதா. See, look here. Elastic means, yesterday we have discussed the definition. Elastic means reluctance to change. After so much effort also, okay, Tambi, understood, more elastic. For so much stress, கொஞ்சம் லைட்டாக சேஞ்ச் ஆகுது, ஸ்மால் சேஞ்ச். ஸோ தட் இஸ் வாட் இஸ் மோர் எலாஸ்டிக். தம்பி ரொம்ப லைட் எஃபர்ட், லாட் ஆஃப் சேஞ்சஸ். கரெக்ட் ஆர் வாட்? ஸோ லுக் அட் திஸ் நவ். இப்போ why I am drawing this line? For equal stress, suppose if I am giving 5 Newton per meter square, if I give, see, if 3 people are there, okay, Raja, Mani and Mrudul. Raja, Mani, Mrudul. So I need to check their six-pack strength. So what I am going to do? I am going to punch. So first punch was 10 Newton. So he was so much struggling. Second punch was 5 Newton. Third punch is 3 Newton. Will I be able to compare the strength of their six-pack? No, I should do 10 Newton, 10 Newton, 10 Newton. Equally, if I am giving force, then I could say how strong they are. Correct or what? So we should check for equal stress. Then only we will be able to comment whether it is changing more or less. Clear or what? புரிஞ்சுதா இல்லையா? So that is why I draw a line here. So now this is equal stress. I am applying a stress on A. This much is the strain. Same stress I am applying on B. This much is the strain. Same stress I am applying on C. Oh, so much of change in length. Strain is more. So which is having less strain, least strain? A. Now our thinking is correct. Least strain. So more, least strain means more. So steel and one brass, rubber. Okay, yesterday we have given the definition of elasticity in physics so that we can give that answer. Otherwise what we would have done? Rubber, brass, steel. Correct or what? Day-to-day life experience you would have given option A. So this is very important. Clear or what? Done? Note it down. Answer? Vyathyasam and answers. Someone said none of the above? Summa soninglo. Okay, so here this is stress, this is strain. So if I mark like this, strain is E for R. Elasticity of P is maximum. Is it true? Elasticity of Q is maximum. Elasticity of R is minimum. Clear? Understood? Cedric? Understood? Done? Okay, so elongation by its own weight. Elongation by its own weight. Okay, so here y is equal to f by a divided by change in length by original length. F by a stress, change in length by original length. Okay, that is strain. So y is actually FL divided by A delta L. FL divided by A delta L. Okay. So if we consider elongation for what we are interested, we need to find the elongation. Delta L is equal to what? FL divided by AY. So what they are asking is, due to its own length, okay, and due to its own weight, okay, due to its own weight, what can happen? Its length can increase. Okay, simple example, if I say, if we take a balloon, and if we are pouring water inside, if you blow with air, it will be happy. But if you are pouring water inside, we are holding like this and we are just hanging it from somewhere, what will happen? It will hang further, or what? Because of the weight of the water, it will come further down, it can break also. Okay, so same situation here. So here the only thing which we need to understand is, suppose if we consider a material like this, okay, suppose if a material is there, if we are cutting this half and this half is applied weight, half is applied with a weight, then what length we will put here? We will put this full L, we will be putting this half L. So this is okay, this is something, some cake piece, okay, cake piece. So what we have done is, if we are putting the weight here under the cake piece, what we will do? The elongation delta L is equal to, if this full length is L, FL divided by this weight is W, so WL divided by what we will be putting? AY will be putting. So same cake, if I am cutting and that half, in the half if I am adding a weight, then instead of this length, what we will be putting? We will be putting what? Delta L is equal to WL by okay. So now here the thing is, here in this case what we must understand is, heart of mass is where? Center of mass. So this is the center of mass. The whole mass is concentrated. The whole mass is here. So we can understand that the weight of the whole thing is actually acting here. The weight of the whole thing is acting here at the center of mass. So because of this reason, by its own weight, elongation by its own weight is nothing but delta L is equal to L by 2AY. So this is the elongation by its own weight. Clear? And by its own weight. Only thing is just divide by 2. Why it is? Because here the center of mass. thermal stress. Okay. See children, suppose if we have a rod like this, if you apply heat on this, what will happen? It will expand. It will expand. So that expansion, this is new length. So new length is equal to old length to 1 plus alpha delta theta. Okay, so this is the old length and this plus alpha delta. This alpha is coefficient of linear expansion. Coefficient of linear expansion. Okay. So wherever temperature comes, same formula. Wherever temperature comes, same formula. Say for example resistance. New resistance is equal to old resistance into 1 plus alpha delta theta. This is temperature coefficient of resistance. Or area into 1 plus beta delta theta. Coefficient of areal expansion. If we take volume, this is nothing but V naught into 1 plus gamma delta theta. This we will discuss this further in thermal properties of matter. Okay, but here I need this formula for covering certain things, so I am introducing the concept. Okay, so simply, okay, new Raju is equal to old Raju into 1 plus alpha delta theta, bus over. Whatever comes, if temperature comes, this is the structure. Fine, clear? Shall I erase them? Okay. So what we need is only this much. Okay. So L new, L old. Okay. All these things we will write in this way. This is L. This is L naught. See children, now if I take L is equal to L naught, if I multiply inside, this will become L naught plus L naught alpha delta theta. So if I do L minus L naught, this is equal to L naught alpha delta theta. What is this? New length minus old length. What is that? Delta L. So I could write delta L is equal to L naught alpha delta theta. And delta L by L naught is what, pa? This is strain. This is equal to alpha delta theta. You could say this is nothing but thermal strain. Okay. So remember, thermal strain is always alpha delta theta. Theta is change in temperature. Okay, children. Okay. Now, what is y? Y is equal to FL divided by A delta L. Here are stress. So y delta L by L is what? F by A. This is nothing but stress. So since this is strain, y into strain is what? Stress. So I could write y alpha delta theta is nothing but thermal stress. Done. Next, another point is force constant. So, what is force constant? Spring constant. Do you remember spring constant? What? How do we constant? Spring F by area F by x. Length of the spring then elongation. X is elongation tangams. X is actually elongation. So why this one we will immediately answer why, because it is very easy to see the springs we have seen. Spring we used to see, but spring if you pull immediately we will be able to imagine, but this is very small change in length. Okay, very difficult to imagine. That is the reason. So just like this is nothing but, suppose if you consider 4 atoms. Okay, suppose if you consider 4 atoms, this is just like this. It's like the springs are connected between all the atoms. Not actually, but it is just like that. So that is the reason, if you try to change its dimension, just like a spring, it will try to regain its original shape. So here, this x is elongation, same constant of wire, this is of spring. Force constant of wire is going to be what? F divided by delta L. Here this is the elongation, here also elongation. So F by delta L. Now how we can put our Young's model? Everyone needs role, Ilya. Drama is going on. Young's modulus will come and tell the director, எனக்கு ரோல் இல்லையா மாஸ்டர், எனக்கு ரோல் இல்லையா மாஸ்டர், எப்படி இப்படி இருந்தால் இப்படி, அவங்களுக்கெல்லாம் எப்போவுமே ரோல் கொடுத்துட்ருக்கு, இந்த ஆளெல்லாம் வந்து எப்போ எல்லா இடத்துலையும் இந்த ஆள் நுழைஞ்சு ஏறாங்க. ஃபர்ஸ்ட் ஃப்ரம் த ஃபர்ஸ்ட் சாப்டர் இட் செல்ஃப் திஸ் ஃபோர்ஸ் இஸ் கெட்டிங் ரோல். எங்களுக்கெல்லாம் ரோல் கிடையாதா? இருக்கிறதே ஒரே ஒரு சாப்டரில் தான், பிலாஸ்டிசிட்டி. அங்கே நீங்கள் வந்து மறுபடியும் ஃபோர்ஸ் கான்ஸ்டன்ட் இதெல்லாம் கொடுத்தீங்கன்னா இது என்ன நியாயம்? ஸோ யங்ஸ் மாடுலஸ் இஸ் கிரையிங், எனக்கு ரோல் கொடுத்து தான் வேணாம், பணம் வேணாம், ஆனால் நான் நடிக்கிறேன். ஓகே, ஸோ எஃப் பை டெல்டா இல்லை, சரி ஃபோர்ஸ் கான்ஸ்டன்ட், பி ரிலாக்ஸ், லெட் மீ சி, ஒரு ரோல் வருது. ஓகே, அடி வாங்குற ரோல் தான், பிரச்சனை இல்லைல்ல. ஹீரோவில் பஞ்ச் யூ, நீங்கள் பறந்து போய் விழுந்துடணும், சோடா குப்பி மேலே விழுந்தா கிளாஸ் உடைக்கணும், அவர் இப்படி தான் காமிக்கும், ஆனால் யூ ஷுட் ஃப்ளை. பரவாயில்ல, எது இருந்தாலும் பரவாயில்ல, நோ இஷ்யூஸ். ஸோ வாட் வில் ஹேப்பன்? ஸோ இங்கே வந்து வி வில் அரேஞ்ச், டைரக்டர் இஸ் திங்கிங் என்ன பண்ணலாம், எஃப் பை டெல்டா, இங்கே எஃப் பை டெல்டா எல்னு போட்டிங்கன்னா, இஃப் யூ புட் எஃப் பை டெல்டா எல், திஸ் ஏ வில் கம் ஹியர், ஸோ ஒய் ஏ டிவைட் பை எல், ஒரு ரோல். ஓகே, வாட் ஒய் என்ன, y a divided by L. So this force constant in terms of Young's modulus, what we can say, ya by L. Ya by L. Okay, so honestly honestly speaking, so when Young's modulus came to act, no, he acted excellently. Idu konja role da, okay, very small role, but he acted excellently. Okay, have you seen the movie Vada Chennai? There is a nice song in that, no? Oru romantic song is there, no? Correct? Suppose if I sing, no, your romantic level will come down to 0. So I don't sing. So in that song, there is one actor. He is coming to the house asking for marriage, no? That small moment of acting, his acting was very good. If you watch that song, you will feel to watch that movie. So his acting is very good. Okay, I don't know his name and all. What is his name? Huh? Amira. Okay. So acting was so natural. Adhe mari da namma Young's modulus. Young's modulus came for a small role. We got stunned how super person he is. Enna problem theriyuma? If I increase the force constant will increase illa? Increase. If I increase this force constant will increase? No. Okay. So if I decrease the elongation, force constant will increase, no? No. So you yourself know that this F by delta L is the formula for solving the problems. Correct or what? No physical meaning, right? But come here. If we change the material, will the force constant change or what? Good. If we change the material, if we make it steel, this guy will change. If we make it copper, this guy will change. So the best form, the real formula, okay, the gold, tangam is what? K is equal to what? YA by L. If we change the length, if we change the area, that is material and dimension, if we change the material and the dimension, what will happen? This force constant will change. Okay, so even though finally got a role, but he is doing his job perfectly. Clear? Neet edit irukumbodhu Young's modulus paatha, hey. That song will come. Okay, right, shall I erase this? Now suppose, see, this, okay. Finding actual length. So this is just like we have a wire. This we have applied a tension on that wire, so its length increased by L1, okay, delta L1. Then we applied another force, another tension T2, then its length is changed by delta L2. After giving this data, they will ask what is the original length. What is the original length? So that process will take lot of steps. I will give you a formula, so just apply the formula and get the answer. So the original length is going to be, so understand, elongation, actual, suppose if actual length of the wire is L, actual length of the wire is L, we are applying first a force, say tension T1. Okay, so its length becomes L1. Okay, say this is the original length. We are applying a force T1, length becomes L1. Okay, we are applying tension T2, length becomes L2. Delta L is change in length, but L1 and L2 is full length, that is a changed length. So this is new length. These are the forces. Clear or what? So in this case, what we will do? We will have to find the L1 is nothing but L plus delta L1, L2 is L plus delta L2. Then we will be putting all the formulae, then we will have to find it out. So not this one, L1 T2, L2 T1, okay, divided by T2 minus T1. Okay, suppose if we take this certain times if you get any confusion in the formula, you have a confusion whether this should come in the numerator or denominator, only that is the confusion. Then always check the dimension. This is what? Meter. Right side also should be meter. So if we take this meter Newton outside, this Newton and this Newton will be cancelled out, right? Correct or what? So likewise, always be strong on the fundamental, so that if you get any confusion also you will be able to come. Last trick, understood? Okay, clear? And in stretching the wire, work done in stretching the wire. Okay children, so here divided by AL, correct or what? Young's modulus Y is equal to F delta L divided by AL. Y is equal to F by A by, oh, inga vandu enna varum? Inga L alla. Okay, okay, right. So Young's modulus is equal to FL divided by A delta L. So force is equal to what? Y A delta L divided by L. Okay, now if we need to find the work, then F dot S allava. Okay, so inga force ku idu podalama. YA delta divided by L into what is the displacement? Delta L. இப்படி எல்லாம் போடலாமா? So answer work done, what will come? YA delta L square by L ன்னு வரும்ல. Is it correct? Correct or what? Any objection? Any objection? யாருக்கும் எந்த கவலையும் இல்லை, நோ அப்ஜெக்ஷன். அப்ஜெக்ஷன் இருந்தால் சொல்லுங்கள், இல்லைன்னா இப்படியே சொல்லி கொடுத்துட்டு ப்ராக்கெட் எல்லாம் போட்டுட்டு இப்படியே பண்ண சொல்லுவாங்க. எனி அப்ஜெக்ஷன்? அதுவோ வருது வருது இப்படி. எனி அப்ஜெக்ஷன்? இப்படி வருது, வாந்தி எடுத்து வைக்க கூடாது. Tell me any objection. Objection இருக்கா இல்லையா? ஒரு சில பேரை கிட்ட இருந்து நான் எதிர்பார்க்குறேன் ஆன்சர் கரெக்டாக சொல்லுன்னு வச்சுக்க, I will throw. Number 1, number 2, டாபிக் சேஞ்ச் பண்ணிட்டு இருக்கு, டிஸ்கஸ் பண்ணிட்டு. Children, any problem in this? மக்களே, அன்பான மக்களே, ஓகே பாருங்கள், இங்க this delta L is what? In the delta L will change, no? If we increase the force, this change in length will change. Correct or what? Okay, so if this change in length should happen, the force should change. For a small extension, a force. For another small extension, another force. For another small extension, increased force. We should increase the force, then this extension will increase. Correct or what? So this formula is valid only for constant force. This formula is valid only for constant force. If the force is variable, W is equal to correct or what? From x1 to x2. Correct. So what should we do? What we should substitute here? So integral from 0 to delta L. This delta L is the total change. 2 millimeter change should happen totally. அப்படி இருந்துச்சுன்னா from 0 extension இருந்து ஒரு 2 millimeter change, say for example. So that is what the total extension is. What is delta L? Now what is force? Y A divided by L. This delta L, dear Tangams, okay, Shokkat Tangams, this delta L is actually full change in length. இப்போ வந்து 1 millimeter, 0.1 millimeter, 0.2 millimeter, 0.3 millimeter னு போகும்போது that extension is variable இல்லையா? This is varying. So from this formula, let us make in this way, like F is equal to YA by L into X we will put. So X நாலே என்ன? Variable. X நாலே from the beginning, right from the nursery or what, from the first standard itself, we are understanding this is variable. Correct or what? A, B, all these things are constant. Okay, that is there. So likewise we will put, நமக்கு ஒரு மன நிம்மதி, ஒரு சாந்தி, ஒரு சந்தோஷம். Okay, so what we will put X and dx. Correct or what? Okay, now you do. So this is going to be YA by L. If we take outside, this is going to be x square by 2. Putting the limit 0 to delta L, what will happen? Work is equal to YA by L delta L by delta L square. Correct? This is the work done in stretching the wire. Work done. Who is doing the work? Who is doing the work? நான் தானே கஷ்டப்பட்டு work பண்ணிட்டு இருக்கு, இப்படி வந்துட்டு இருக்கு. I am doing the work. External force. Okay. When I am doing the work, okay, external force, then this wire will do. Okay, same force he will apply inside. Then what I will do? I increase the force. What this wire will do? Okay, so inga poti, anga poti, inga poti, anga poti. Rendu veru apram bala bala. Correct or what? Correct or what? That is what. Clear? So what will happen when I am stretching? I am doing work. This work will be stored as what? Stored as முட்டாய் வாங்கி தரேன் சொல்லு. பொட்டன்ஷியல் முட்டாய் வாங்கி தரேன். பொட்டன்ஷியல் இருந்து சொல்லுங்க சத்தமா. This work will be stored as potential energy. சில பேரெல்லாம் திட்டம் போடுறாங்க சொல்லக்கூடாதுன்னு சொல்லிட்டு. Okay, so this is the work done. Okay, so work done in stretching the wire will be half YA delta L square divided by L. Okay, clear? Okay, இப்போ இது ஞாபகத்தில் வைக்கிறது கொஞ்சம் கஷ்டம் தானே. Y A delta L square by L. Difficult to remember, no? கஷ்டமா தானே? கஷ்டம் இல்லையோ? சரி, புதுசா ஒரு மெத்தட் சொல்லலாம்னு நினைச்சேன். உங்களுக்கு பிரச்சனை இல்லைனா children, நம்ம யங்ஸ் மாடல்ஸ் நடிக்க வந்த போது how was the performance? அருமையா இருந்தது இல்ல? சூப்பர் பெர்ஃபார்மன்ஸ் இல்லையா? ஸோ அங்க அந்த நடிப்பில் what is the formula of this one? YA by L. What is work done in spring force? Half kx square allava. So just substituting, what is this? Half ange kuttum. What is this, children? அது யாரு? அது ராஜுவா, டேவிஸா, இல்ல மதுமோகனா? யார் இது? elongation சொல்லுங்க. elongation. So this is elongation இல்லையா? அங்க elongation என்னது? What is? Able to understand? So this is nothing but our simple work done in stretching this half kx square now. This fellow is this fellow is this one. Done? You will be able to remember this. Okay, Shri. Now, what was the formula for force? Y A இதுதான்ல. This is what is force. So this W is equal to half into this is YA L square allava. So YA delta L and if we write here delta L separately and divide by L, okay, can I write work is equal to half into force into delta L. So mother formula, the first, but half into YA divided by L delta L square. This is the first formula. Second formula is Y is equal to what? Half into force into delta L. Here. Okay, done. See, children, suppose if I divide this with A, if I divide this force with A, then I can multiply this with A, and if I divide this with L, then I could multiply with this L. So idu yaar? Stress. So work is equal to half into stress into strain into volume. Okay, so work done is equal to, third formula is half into stress into strain into volume. Okay. Now suppose in this formula, right, everything is noted down, right? Shall I erase? Okay. Okay, so this is first formula. Where is the second formula? Okay, so this is the third formula. Fine. Right, so we'll write everything finally. Now see children, here work is equal to half into YA by L into delta L square. Suppose here if I write L square, I can multiply this with the L, correct? So then what is this? Strain square. So can I make any other adjustments for making any other formula? Any other adjustment? Any other adjustment, children? Let us try. Y is equal to half into this y, let here. If I take this L, okay, y by L is here. This L I am going to put here. Then delta L square by L square, let it be there. Then I am putting A into L here. Okay, so this will become volume. So work is equal to half Y L by L. I am not cancelling, wait. This is equal to strain square into this is equal to volume. Now can I do something here? Any idea? What? Nothing. Okay. Any other? What? Then I will have to multiply with the A. Then again divide with the A. No. Then what I will do with that A? Cut. So the fourth formula is this one. Work is equal to half into Y into strain square into volume. Done. Okay. Shall I erase this full? Okay. Done. Okay. Going to erase. Okay. 1, 2. Okay, so force constant K is equal to what? A by L. So first formula, work is equal to half YA by L into delta L square. Done. Second formula is work is equal to half into force into delta L over force into delta L. Third formula is work is equal to half into stress into strain into volume. Done. Then fourth one, half into y into strain square into volume. Done. Over. This is the work done in stretching the wire. This is the potential energy stored in the wire. Okay, all are same. This is also correct, and potential energy stored inside. Shall I ask you one thing? Suppose if they ask work done by the external agent. Work done by external agent. This is correct. Work done by the external agent in stretching the wire. Is there any problem? No. Suppose if the question is work done by the wire, then what else will come? See, suppose you can take this example. This elongation is happening in this direction. Elongation is happening in that direction. What will be the direction of spring force? Opposite direction. So what will be the direction of force inside the wire? What will be the direction of restoring force? Opposite. So this will be the direction of elongation, is delta L or X, whatever it may be. This is going to be the direction of restoring force. That will be the direction of restoring force. If that happens, no other difference, minus. Clear? So this is same as the potential energy stored in the wire. So potential energy, what will be the sign? Plus or minus? Plus only. In work power energy, I will take it in detail. Please understand that potential energy is equal to negative of the work done by conservative force. Potential energy is the negative of the work done by conservative force. The conservative force which we are applying here, it is actually the force by the wire. Elastic force, that is conservative force. So the work done by the conservative force will have negative. Work done by the conservative force will have negative. Work done by the wire will have the negative. So potential energy will not have negative. Work done by external force also will not be having negative. Nothing is mentioned in the question. We need not worry about all this. Clear? They will try to test like this. After the exam, we will be telling like this time Neet was very easy. All these tricks might be hidden there. They might have asked what is the work done by the wire. We will apply this. Okay, already we might have studied like without negative. So we will happily mark the answer. After checking the key, we will be telling like this time I will be having 692 marks. Correct or what? When the key is out, story will be different. So small things very சின்ன விஷயங்கள் தான். சின்ன விஷயங்கள் மேல கவனம் இருக்கணும். Okay, clear? Done? Okay, fine. See children, another thing which is associated with this topic is energy density. Energy density. What is generally density? Mass divided by volume. Energy density means nothing. Energy density divided by volume. So sorry, energy density is nothing but energy by volume. This is going to be Energy density, suppose if you put as small u, okay, energy density, suppose if I am putting as small u, this is going to be nothing but half YA delta L square by L, just divide by volume. Okay, then remaining all the things you can do. Second one, again half into force into volume. Third formula, what will happen? Half into stress into strain. So half stress to strain, these kind of formulas examiners know, they like very much. In the volume இருக்கிறது பிடிக்காது அவங்களுக்கு, அவ்வளோ பிடிக்காது. They will like half stress into strain. Correct. அப்புறம் small tricks like negative and all they like a lot. So the chance is like they will ask energy density, and if they want to test you too much, they can play with negative. That's it. So these questions we can see actually. U is equal to, this one is half into Y into strain square. So energy density is half stress into strain. Okay, energy density is half into stress into strain. Suppose if I put here thermal stress, and here if I put thermal strain, then what this is actually, this is going to be density, thermal energy density. What is thermal stress? Alpha delta theta, alpha delta theta. Thermal stress Y into alpha delta theta. What about thermal strain? Alpha delta theta. Is it correct? Okay, Y alpha delta theta into alpha delta theta. So you need not by heart all these, whatever that basic fundamental things you can remember. Just thermal energy density is asked, simply half thermal stress into thermal strain. Remember that, then put the formulas and get the answer and look at the options. So I won't be doing all these questions, children, because once if you know all these, then those are all direct. Just for practicing, I will give you questions. Okay, that will be sufficient. Clear? Any doubts so far? Elasticity. So some Y will be given, delta L will be given, finding energy you will put and find it out. No. Okay, for this material this much is the elongation, for another material that much is the elongation. What is the ratio of energy density? You will do now. Okay, correct. So those things we don't need to do much. Correct or what, children? Okay, done. Take this question. Okay, so Three blocks, children, 3 blocks. Okay, so they are all of same mass, M. Okay, connected with the wires W1, W2. Okay, same cross-sectional area. Okay, same area. Okay, same area. So they are connected with the wires W1, W2, same cross-sectional area. Okay, and these wires have same Young's modulus also. Same Young's modulus also. Okay, clear? Okay, strain developed in the wire W2. Question is, strain developed in the wire W2. Strain developed in the wire W2. So the wire is of same material, same Young's modulus, same area. Why they have given W1 and W2? Because they are interested in the strain of this wire. That is the only difference. Clear? Okay, so shall I give you the options? Third option. Option. Consider those two masses as single mass. Then just find the tension. You can you know the formula, right? Directly the tension. Just once if you find the tension, T by A. Children, I will give you the hint. Find the tension of this wire. Then area is given already. This is not that tough, easy problem only. But then when we see laws of motion and suddenly strain, we will feel uncomfortable. So do these kind of questions. First one. True, correct. Okay, done, children, got the answer? Okay, so this is nothing but what is the formula for tension? Suppose, see this, you just see in this way. Okay, just if we take, if you have only one string, then how you will do? If this is how the masses are, then what is the formula for tension? If this is M1, this is M2, what is the formula of tension path? M1, you have a direct formula for finding the tension. What is that? Minus M1 now. Just a single formula. M1 M2 for this case
plus m.
divide by simple formula, no, just if you have a pulley, two masses, divide by plus M2 divided by here. This is what? So is it 2m1 m2 divided by m1 plus m2 into G? Okay, simple formula. Remember these kind of things. Okay, otherwise no need to cancel all that, then don't waste time then. So if you do this, then you can consider this as single mass. You can consider this as single mass. So the tension is going to be what? So this is one wire. We are interested in strain developed in wire W2. So we are interested in this wire. Okay. So the other one is going to be 2 into 2m. This one is m divided by 2m plus m into G. Is it correct? Correct or what? So this is going to be 4m square divided by 3m of G. Is it correct or what, children? Wrong. You are correct. Then what is the mistake? Which 2 won't come? Here. In this formula. Then what is the correct formula? Only m1 m2 divided by m1 plus m2. Yeah. 2 will come. Okay, let us see. Varada. See how to see. Take this children. See, look at this. Okay, done. See, suppose if you have a pulley like this, if you have, say for example, mass here, and if you have 2m here, this will be moving with an acceleration a. This will be moving upward with an acceleration a. This is going to be mg. This is going to be tension. This is going to be tension. This is going to be 2mg. Correct? Then what will happen? This is going down. So 2mg minus T is equal to what? 2ma. This one, T minus mg is equal to ma. When you add this, what will happen? This T will be cancelled off. So this will become what? 2mg minus mg is equal to what? 3ma. Okay, 3ma. So this is going to be what? mg is equal to 3ma, and if we cancel these two, we will be getting acceleration equal to g by 3. So this is the direct method. This is the direct method. Instead of going for all that, we will be doing that direct method. Means using the shortcut. Clear or what, children? Okay. Right. So what will come? Remember this. Okay. Remember this one. We'll finish this. See, the thing is, T is equal to m1 m2 divided by m1 plus m2 into G. Is it correct? Or m1 plus m2 by m1 m2? Is it? This is correct. Okay, done. So what will happen in this case? M1 is going to be 2m and this is going to be m divided by 2m plus m into G. So 2m square divided by 3m into G, m can be cancelled off. 2 by 3 mg. So what is the strain? strain is equal to 2 by 3 mg divided by A. Or what? Okay, so option. Done? Note it down. So simple thing, children, simple thing. See, this pulley masses, all these things can be too much. Lot of combinations are there that we don't need to study that much. That will come only for JE, and for JE advanced level, more pulley mass cases you should practice. Suppose if you are preparing for that. But fundamentals is this. Okay, laws of motion, whatever fundamentals from laws of motion that you can apply, that will be there. But remember this formula, because simple cases with some other chapter concepts like this can come always. Okay, so remember M1 M2 divided by M1 plus M2 into G. This is the tension formula for this case as well as this case. Since two masses are given here, no need to just confuse. This can be considered as mass M1. Clear? Done? Okay. Any confusion, any doubt so far? Okay, now I will give you one small tip. We will do one problem, then after that we will generalize. Okay, see. Suppose if you have different wires like this, okay, if this is a roof, we have connected one wire like this, okay, another wire is connected like this is different, another wire is connected, okay, just this is shown just to show that they are all of three types. Suppose first one's Young's modulus is 2.5 into 10 raised to 10 meter square. The second one is 4 into 10 raised to 10 Newton per meter square. Third one, y is equal to 1 into 10 raised to 6 Newton per meter square. This length is 0.1 meter. This length is 0.2 meter. This length is 0.15 meter. We have attached a weight of 10 kg here. Okay, we have attached a weight of here. The area cross section is 10 raised to minus 4 meter square for all of them. Okay, area of cross section. So area is equal to 10 raised to minus 4 meter square for all. Okay, clear? Okay, one more thing is there. The entire rod is a light rod. Okay, light rod. Done. Now what we need to understand is what is the displacement of the point B. Displacement of the point B. Okay, B, C, D. Displacement of point B. Displacement of point B. Okay, so displacement of point B is asked means nothing but what is the extension for this first wire? Displacement of this point B means what? What is the extension for the first wire? So what is extension? F L A Y. So F L is nothing but MGL divided by AY. So this is light rod they have mentioned. So we need not consider the weight of the rod. We need not consider the weight of the rod. We need to consider only this 10 kg. So each information given in the question we can make use. So 10 kg into how much is that length? 0.1. Area is given as what? 10 raised to minus 4. What is the Young's modulus? 2.5 into 10 raised to 10. So this is easy, no? This is going to be 4 into, once if you get this, look at the option and mark 10 raised to minus 6. Okay, same way for the extension or the displacement of point C is nothing but again same, 10 into, here the length is going to be 0.2 divided by what? Area, 10 raised to minus 4, and its Young's modulus we will have to take when we need to find the displacement of point C. Okay, so what is Young's modulus here? 1 into 10 raised to 6. Is that fine? Will that be okay? Then
displacement of field.
Thing is, this extension alone is how much, children? Just tell me. This extension alone is how much? This is going to be 2. So 2 into 10 raised to what will come? 10 raised to minus 2. 2 into 10 raised to minus 2 is. So the displacement of this point C means what will happen? This length also we consider and this length also we should consider. Then add them and write. Then tell me what is the displacement of point C, how much you are getting? Displacement of point C is how much, children? This is 4 into 10 power minus 6. Here okay, right, 4 into 10 to the power 10, right. So how much will come? So yes, so this is going to be 5 into 10 to the power minus 6 will come. Is it correct? 5 into 10 to the power minus 6 will come. Okay, so this is elongation of what? BC. Is it correct or what? 5 into 10 to the power minus 6. Actually here also 10 will come. Here also 10 will come because this is 10 kg. So this is correct. This one is also correct. Only difference is 10 will come. Now the elongation, displacement of point C. Displacement of point C is nothing but 9 into 10 raised to minus 6. Correct? 9 into 10 raised to minus 6. So associatively for point D also you need to find this elongation, this elongation, add all of them so that much displacement will be happening to point D. Clear? Understood? Any doubt in this, Mukesh? All of you? So what we are doing actually, What is the effect of Young's modulus? Young's modulus, suppose total elongation if we are considering, if all of them are constant, then what will be the effect on the Young's modulus? If all of them are saying, what is the effective Young's modulus, I am asking. That is, say for example, if this length is same, this length is same, this length is same, this is light rod, so the force on all of them are same, area of cross section is same, everything is same, only Young's modulus is different, y1, y2, y3. If it comes like that, what will be the total elongation and what will be the Young's modulus then? We will be able to take everything outside, no? F divided by A into L, everything we will be able to take outside. If only Young's modulus is different, what we will be able to write? 1 by y1 plus 1 by y2 plus 1 by y3. So if we connect them in series, okay, the Young's modulus will be like this. Done? Clear or what? Understood?